Hello and welcome back. Okay, today I want to get the next big chunk of the ALU, which is the logic unit. It does bitwise logic that uses both the RHS and the LHS inputs, turn it into a PCB to fit this gap. Now I'll still need a wire from the output back to this breadboard, but we can get rid of one of these wires and 3 of these breadboards once it's done. So the LHS unit, the shift unit, is still here, but we need it just to make the connections and not have all of these wires be too long. But yeah, we're going to halve the size of the ALU if this works. Right, let's get on with that. Okay, so here's the inputs we've identified as necessary for the right hand side. That's the logical unit of the ALU. This is the space we've got reserved for it on the current backplane, so hopefully we'll be able to fit it all in. I'm also hoping it's going to be a slightly easier fit than the LHS side. I think we can steal a bunch of this though. Pretty much the same apart from we're doing the logic output. We do want some LEDs. This is going to be really easy compared to LHS, I think, just because of so much work we can just copy. Now, can we copy any of this? That would be really cheeky. Curious to see what it's done there. These wires have the wrong trace ID on them, and because it's looking for net connecting to net in appropriate IDs, that's not working. I could click on them and rename them, but it's going to be quicker to actually just redraw those traces. It's lost the capacitor as well. Same problem there. Okay, I think the only thing I've actually saved myself there is lining the LEDs up. Now the core work is done by 8 of these. That's output. That's part of the input. Now on the breadboard version, it was the upper side of these I used, so I don't have a good reason to not do that. And the 4 inputs are literally just these. So left-hand side input goes to S0 and the right-hand side input to S1. So this half of the chip we're not using because both selectors share S1 and S0. Okay, so we just need 8 of these, one for each bit of the input and output. See, what I really should do is get the capacitors into the circuits next for chips. Why do these always come through as U and not C? Probably makes no difference at all. I don't think I'm going to use that either in this one. Right, now if I'd put RHS over there, then I could perhaps have done them here in 2 rows of 4. Or if I'd put this output over to the right, I could have done it vertically here. now I think we have a completed layout. So I can get my labelling up in here. See how easy to route this is. I'm suddenly thinking, if we alternated which side we used as connections here, those would be really short wires. I think they're going to be fine anyway. The best way to think about the way this unit works is each of the bits of LHS and RHS are completely independent. So we basically just got 8 copies of the same circuit, 1 for each bit. But then we take the bit of LHS and the bit of RHS and just use that as a binary lookup onto these 4 wires. So these 4 inputs basically form the truth table. Tiny leftover bits of wire like that are an unforeseen problem with copying around chunks of PCB. I see, I've got all of these wrong. This would make more sense if it was the other way around. Yeah, I'm going to turn this around. It's going to make this a lot neater. Now, inevitably you're going to see this before you see the LHS or RHS PCBs, so you've got to look in hindsight and see why I randomly turn these around. Doesn't necessarily make this side any easier though, does it? I'm just thinking, instead of making these ground, if I gave them the same inputs as those, this would actually make routing this much easier. It's weird, it doesn't want to take the same path as will match up with what I've done elsewhere. If I had thought about this in advance, I could potentially have done a lot of these in common interconnects with a paste. Right, so the main thing here is we've got 2 inputs to each chip and 1 output from each chip. I need to work out the right way of routing them all. See, this is interesting. Now I'm pretty much done with this layout, apart from ground. You see at the moment my ground trace comes over to here, up to here, but then it just stops. And all the grounds are cross-connected over here, but they're disconnected. Now I'm going to use a ground fill plane, but we do need to make sure that we don't have like islands with only a small line of connection back to the ground pin. Now if this looks a bit weird, it's just because I know I'm going to be ground filling here, and I'm just making sure that these two big chunks of ground plane are going to end up being stitched together properly, and so I'm joining them up with wires just so I know the path is there. No DRC errors, that's looking done. Right, let's get those copper fills in. I feel really good about this. It's going to be a nice looking board. I'm actually a little bit jealous that you will be seeing the physical PCB immediately after this, and I'm going to have to wait a few weeks. Right, let's take a look at these. It's a nice little board. Right, that looks okay to me. Put a bit more effort into preparing my components this time round. It would be incredibly easy to get these ones the wrong way around. Okay, I think they're all the right way around. Right, I think that's all the components on correctly. Okay, that's looking pretty good. Looks like it could be bridging there though. So the solder paste just didn't flow as well this time as I'm used to. I suspect the paste is getting old and the flux is drying out in it. Okay, that should be the bitwise logic board. I'm going to clear my desk up, get the main build out, and we'll give it a test. Right, let's see how we can get this in. Shouldn't be as difficult as getting the LHS in because all of these connections are in common. Right, already fed over the control lines for it. But we obviously do need to still bring the output over here. In theory, that's it. And that has worked perfectly first time. I need to clean this PCB a bit though because I've got some extra flux on. Okay, a whole bunch of this isn't needed anymore. Alright, so actually got a bit of extra space. Can I use it productively? I'm really pleased with this. I think I'll do the ALU control next. That'll get rid of a lot of this mess of wires. Well, that's back to having two PCBs in a row that worked first time, so I'm pretty pleased with that. The bodge necessity on this hasn't turned into a trend. It's nice being able to move stuff around, particularly now I've got these extra bus connections. It means I'm not restricted to exactly where I put anything. So these are blue LEDs, so they're the bus inputs, and then these are the results from the two stages that are going off here. But then the bulk of the work here is what's on the board I've named result here. And the control is going to be the diode matrix and a couple of bits of the additional signal generation. Well, I hope you found this interesting. I know I'm just kind of converting breadboards to PCBs at the moment, so I'm not really exploring any new concepts. Okay, thanks a lot for watching. Hope you found this interesting, and I will see you again soon. Goodbye.